Hello children, in our last discussion we discussed about combination of cells, but practically in any electric circuit there are many resistors and cells and they are interconnected in a complicated way. To solve such problem, only series and parallel combination is not sufficient. To solve such problem, there is two law given by Topic-Kirchhoff, a German physicist, which is based on symmetry. So let us discuss those two laws, and if you missed the previous content, then visit the link here given for the previous one, and in the last you will find there's some questions for you as assignment and some of question as test. For test, link is given in the last of the video. So let us discuss one by one the Kirchhoff's law. Kirchhoff's first law is known as Junction Rule or current law. The algebraic sum of electric current at a junction in any electrical network is always zero. That is, summation I is equal to 0. Let here at point O, it is called the junction, means some currents are coming at O and while some currents are leaving. If incoming currents are taken as positive and outgoing current are taken as negative, then from the junction rule we can say I1 minus I2 minus I3 plus I4 minus I5 equal to 0. So remember the sign convention. Incoming currents taken as positive at a junction, while leaving from the junction is taken as negative. So it is the purely conventional. You may take in a different way, that is outgoing positive, incoming negative, result will not change, but suggestion is always follow any one of the sign convention. This rule is based on the conservation of charges. Now the second law, which is known as the voltage law or the loop rule, the algebraic sum of all the potential drops and EMFs along any closed path in an electrical network is always zero. So that is summation IR is equal to 0. Here just see an electric circuit, combination of cells and resistors. Very difficult to say which one is in series and which one is in parallel. But by using Kirchhoff's rule, we can solve such problems very easily. Here, the direction of currents are given from the cell E1 I1 current, from the cell E2 I2 current. The direction of conventional current is taken from the positive terminal. Here it is not given, so we have considered. And at point A, two currents are coming. So obviously by using conservation of charges, these two current has to leave. And again at point C, this current I1 plus I2 is coming. So C2B means towards the resistor R1, I1 current, and towards R3, I2 current. Let here first the closed loop ABCA, this loop. That is, we starts from here. First, know the sign convention. If we travel through a cell from the positive to negative, EMF is taken as negative, and the vice versa. While we travels from negative to positive, EMF will be taken as positive. Through a resistor, if we travels opposite to the current, because current flow from high potential to low potential. So opposite to the current, that is positive, in the direction of current, negative. Once again, I am reminding you, the sign convention is purely based on us. So here in loop A, B, C, A, see first we have to here reach the positive terminal, then we will reach the negative plate. So the EMF is negative, that is minus I1. Now over this R1 resistor, we have considered the loop A, B, means we are moving A to B, and the direction of current is B to A. So the EMF across this resistor will be positive. That EMF will be, any voltage drop will be I1 R1 here plus. Here no any resistor or the cell, so nothing here, no voltage drop. It is simply a connecting wire. Now C to A, first encounter a resistor and again we move C to A, so it will be positive and that will be plus I1 plus I2 into R2 equal to 0. Similarly, in the loop ACDA, now we are moving from A to C, so in the direction of current, so it will be minus I1 plus I2 into R2. Now C to D, so again minus I2 R3. Here come negative to positive, we have to cross, so it will be the positive one, so plus E2 equal to 0. So it is a way. Once again, what is the sign convention here? The EMF taken negative when we traverse from positive to negative terminal of the cell through the electrolyte, and it is taken as positive when we traverse from negative to positive terminal of the cell through the electrolyte. Now the potential falls along the direction of current in a circuit path. It rises along the direction opposite to the current path. The potential fall is taken as negative, means finally let it be here. If we move B to A, means and current is also moving B to A, so obviously B is at higher potential and this point at lower potential, so finally we are reaching at lower potential, so potential drop across R2 will be taken as a negative. Now what are the problem solving techniques? Because one question generally every year in the board examination as well as Kirchhoff's rule very much important for competitive examination. First, just see the junction rule, which is based on the conservation of charges. Here see I1 current is coming in, I2 I3 leaving, so I1 equal to I2 plus I3. Loop rule, which is based on conservation of energy. Follow a test charge Q around a loop, then what will be? Summation of charge into change in potential, that is equal to 0. Now here see, changes going from left to right here. In all case, we are moving left to right. Here see, the direction of current is left to right. So the potential drop change in potential across R will be minus, that is minus IR. Now here we are traversing left to right while current is right to left. So change in potential will be positive. We are traversing left to right. So first we encounter the negative terminal. Then we have to reach finally at positive. So change in potential is positive. Now in capacitor, what is change in potential? That will be Q by C. So in the Kirchhoff's rule, in competitive examination as well as in CBSE, sometimes in place of capacitors, inductors are used. Capacitor we have seen, about inductor we will see later on. Now let a problem. A battery of 10 volt and negligible internal resistance is connected across the diagonally opposite corners of a cubical network consisting of 12 resistors, each of resistance 2 ohm. Determine the equivalent resistance of the network and current along each edge of the. Here see the diagram. So it is a complicated problem. We can't say it is in series or in parallel. So first what we have to do in while we solve a problem by using Kirchhoff's rule, we have to see whether any symmetry is there or not. In the most of the cases we will find there is a symmetry. Now how we can check that one? See, the entry point is A and exit point is C dash. If some current is going here, A dash, D dash, C. See how many paths? Here 3 resistors. If current follow the path A to B, then here B to D dash and C dash, again it is 3 paths. Similarly, we can check A, D, C dash, will find 3 resistors. Or anyway, A, B, C dash, A, D, B dash, C dash. So, each point is symmetrical. Means whatever current will go through this one, whatever current will go through this one, whatever current will go through this one. If resistances are same, then equal amount of current will go. Since here it is given the resistors are equal, each of 2 ohm, so equal amount of current. So let it be the current supplied by this battery is 3I. So what will be here? See, A to see here 3I current we have taken. So along A dash I current, along AB I current, along AD I current. Now take any point A dash. Again from C here, exit point. A dash, D dash and C dash. So 2 resistors. Along this one, A dash, B dash and B dash, C dash, again 2 resistors. So this point and this point is symmetrical. So equal amount of current will distribute. So A dash, D dash in this resistor I by 2 current, and also along this I by 2 current, because at this point I current is coming. So total incoming current must be leaving current. Similarly, from B, current will be in each arm I by 2 and I by 2. Again, from D, along DB dash I by 2 and along DC I by 2. Again come to the point D dash. See here I by 2 current is coming, and from this side I by 2 current is coming. So now I current will leave. Similarly, from B dash I current will go towards C dash, and C to C dash again I current. So total 3I current will leave out the circuit. So it is, if we take the I, then here it will be I by 3, I by 3, I by 3. Again I by 3 will divide into 2 parts. So I by 6, I by 6. So just for simple calculation here we have taken 3i. Now if we use the Kirchhoff's loop law in the closed loop A, D, C, C dash, E, A, then what will be? See here, A to D, it will be, we are moving along the direction of current, so minus IR here. Now D to C again along the direction of current, so minus I by 2R. Similarly, C to C dash, it will be minus IR. Here no any resistor, so no voltage drop. Now come to here. Negate, we have to reach at A, so first negative terminal to positive terminal. So here EMF will be positive, so that is 10 volt equal to 0. And on simplification we get IR equal to 4. So what is I equal to? It is 4 by R, and R is 2 ohm. So I equal to 2 ampere. Now in which arm I current, there the 2 ampere current, where I by 2, that will be 1 ampere current. So the total current in the circuit is 3I. So that will be the 6 ampere. If we consider the equivalent resistance of this whole circuit, that is R equivalent, then R equivalent equal to V by total current. So here V is 10 volt and total current is 6 ampere. So R equivalent is 5 by 3 ohm. Next problem here, see, obtain the total resistance between the terminal A and B. A point is here and B point is here, that is shown here in the given network, or find the effective resistance of the given circuit. It is the question, and here it is the solution. First, from the cell, in this question the direction of current is not given, so we have considered the direction of conventional current from the positive terminal, that is I. Now at this point current has to divide, since resistance are not same, so unequal current will go. So let through 1 ohm resistance I1 current. If we use the Kirchhoff's junction rule here, then it will be I minus I. Remember, though we can take here the I2, but as many consideration that much will be the number of equations. So here here we have taken I, another I1, so this side will be I minus I. At point C, I1 current is coming, and again here the two resistance, so current will distribute. We may consider in a different way that this current is coming and going in this way. We will try. Here we have taken that from C to D current is going, that is I2. So from C to this side, that will be I1 minus I2. Now at D, I minus I1 and I2 are incoming current, so that much current has to be. Total if you add these two currents reaching at P, you will find its value will be I. Now see here we have taken it is the clockwise, that is KVL in the loop A, C, D, A. What will be? Once again minus I1, minus 3I2, and this will be the plus 2I minus I1 equal to 0. From this we will get 2I equal to 3I1 plus 3I2. Again if we use the Kirchhoff's voltage rule in loop CBDC, we will get this equation. Using 1 and 2, we will find I1 equal to 13I2, and again using KVL in the loop ACBVA, means this way. You may take this way, the result will come the same. So hope in that way you will try. Equation will be here once again minus I1 minus 4I1 minus I2 plus V equal to 0. So from here V equal to 61 I2. If we take equivalent resistances are equivalent, then what is the V equal to? V equal to I R equivalent. So here this value I equal to, we can substitute from here. This from equation 1, we will find its value is 21 I2 R equivalent. And here see V equal to 61 I2. So if we equate these two, we will find R equivalent equal to 61 by 21 ohm. Hope you have understood. Try yourself these two problems first and few more problems. Now, 3 questions here given as assignment, and after watching the content, if you have the problem, once again repeat. If not, then go for a test. The link for the test is here. Thank you. All the best.